What we're talking about when we talk about fax is the ITU T.30 Group 3 recommendation from 1980. ITU is the International Telecommunications Union. T.30 Group 1 was introduced in 1966 and transmitted analog data with no compression, a low resolution of 96 dpi, and took 4 to 6 minutes per page. T.30 Group 2 debuted in 1978. It was also analog, but introduced a simple compression algorithm which improved speeds to 2 to 3 minutes per page. T.30 Group 3 arrived in 1980 and defined digital data transmissions, better compression algorithms, multiple resolutions up to 400 dpi, and transmissions less than 1 minute per page, depending on resolution. This ITU recommendation became the worldwide standard. Other revisions, such as Group 4 and color faxing, were never largely adopted as businesses quickly realized that interoperability was the primary concern, and most of the world's fax machines were Group 3. The ITU recommendations for Group 1 and Group 2 were officially withdrawn as obsolete in 1996. Traditional faxing takes place over the PSTN, which is the public switched telephone network. The direct path between the sender and the recipient is also known as a circuit switched network. This is effectively a point-to-point connection. Once the circuit is assigned to you, it's yours exclusively until the end of the call. With the commercialization of the Internet in the early 1990s, it was suddenly possible to cut down on long-distance and international telephony charges using voice-over-IP. For an organization that relies heavily on telephone communication, this was a dream come true, especially when global markets were involved where you had local offices. Least-cost routing meant that your voice calls could enter the PSTN at the location closest to your call destination, substantially reducing long-distance and international dialing fees. But while this technology was great for voice calls, it created serious problems for fax. The voice-over-IP integrators were quick to sell analog add-on cards for legacy telephones and fax machines, while failing to mention that their systems and codecs were optimized for human voice in the way that humans hear speech. These systems were never intended for the screeches and squeals of fax communication. Consequently, the quality of fax communications dropped to practically unusable levels. In a business context, it was completely unacceptable. Organizations were forced to maintain landlines at each office location for the exclusive use of their fax machines at significant cost, and while losing all of the least-cost routing that voice-over-IP had promised them in the first place. So what is the problem? Well, getting back to our train analogy, when a fax transmission traverses an IP network, a local network or a wide area network, it's chopped up into packets. That's why modern data networks are called packet-switched networks, and the PSTN is a circuit-switched network. Each switch track, the green dots, represents a router, and each router will choose the best route for each packet. You admins are all familiar with traceroute or traceRT. Each hop creates a delay, and as network quality changes during your fax transmission, the routes taken by each packet may change. Now, instead of a continuous stream, our fax transmission is split into individual train cars. Depending on network congestion, quality of service rules, and network design considerations, our train cars may take different routes, may be delayed, may arrive at their destination in a different order, or may not arrive at all. Packet loss. For most things that we do on the internet, packet loss is no big deal. The underlying systems can buffer the data to give missing packets time to arrive. They can reorder the packets to put them in the correct sequence, and if it takes a few extra seconds for your web page to load or for your download to complete, it's no big deal. And you may say, my voice-over-IP calls are working okay over this network. Why not fax? We're all familiar with talking over voice-over-IP with huge delays. 1 or 2 seconds, 1,000 or 2,000 milliseconds is annoying, but you can still communicate. Sometimes there are gaps. missing syllable here and there, but you can follow the conversation because your brain is really good at filling in the gaps and recreating the missing data from context. In the days when the PSTN was the only thing connecting one business to another and fax machine protocols were being developed, those kinds of delays and gaps just didn't exist 99% of the time, unless you were calling Outer Mongolia or something. The authors of T.30 assumed, as do most engineers on the bleeding edge of technology, that things could only get better over time. But the fax protocols that they developed for the world of 1980 were simply not flexible enough to tolerate the problems that IP telephony introduced in the 1990s and beyond. No one saw it coming. Now, I know a lot of you are too young to remember a world before mobile phones and voice over IP, but I can tell you that we lost a lot in terms of audio quality and call reliability. And I can also tell you that not one of us would have it any other way. So as they say in Texas Hold'em, we have to play the cards that we've been dealt. Taking all of these factors into consideration, the ITU stepped in around 1998 and created a new telephony recommendation which they called T.38. The goal of T.38 was to allow real-time fax transmissions to be simulated over packet-switched networks. It's more or less a way of tricking a T.30 device and its 30-year-old brain into thinking that it's communicating over a standard PSTN, using send-receive buffers, carefully timed error correction requests, and some subtle rule bending. For instance, if the buffers start to get low, the protocol can step in and make an error correction request even though no error was detected. This causes the sending device to stop and retransmit the last piece of information, giving the buffers time to fill up again. But this trick has to be used sparingly, because too many error correction requests will cause the sending device to give up, because the T.30 protocol tells it to. Alternative technologies? T.37 is an ITU standard which deals with the sending of fax messages using email. It's also referred to as iFax, Internet fax, or store and forward fax. A fax machine supporting T.37 will send a fax to an email address by converting the document to a TIFF image, attaching it to an email using MIME format, and sending the document using SMTP. The destination fax machine receives the email and prints the attached document. To interface with regular fax machines, T.37 can be used in conjunction with fax gateways to communicate with regular fax machines. The fax gateway converts emails to regular faxes or regular faxes to emails. A T.37 compliant fax machine includes legacy fax functionality to send to regular fax numbers and requires a phone line for this. A repository for matching fax numbers to email addresses has been proposed but never implemented, leaving T.37 configurations to fall back to T.30 nearly 100% of the time. G726 was an early ITU attempt to address the problem, but was often implemented poorly and even under perfect conditions was only capable of 9600 bits per second. Just a few years later, the World Wide Web came along and dial-up modem speeds of 14.4 and 28.8 were common. By the end of the decade, fax machines supporting the V.34 bis standard were available and capable of 33.6. G711 has caused quite a bit of controversy over the years, at least in terms of fax communication. It's a lossy compression codec designed to conserve bandwidth and optimized for human speech, although lossless compression is also an option. It's nearly always implemented as UDP without packet redundancy, because the audio gaps created by missing packets in a VoIP call are easily interpolated by the human brain, as we've already seen. The problem with G711 and fax comes from the fact that fax machines can't interpolate data, so even a single missing packet can be fatal during a fax call. The combination of audio compression and no error correction UDP generally results in poor fax performance. Use G711 for fax only as a last resort. It is supported by Faxination, but not recommended. Don't blame us if you're not happy. The two common signaling protocols for T.38 are SIP and H.323. The fax-over-IP solution that we recommend will be based on your telephony system, recommendations from Dialogic and TE systems, and our own personal experience. There's also MGCP, but that's more or less proprietary and used between a Cisco call manager and a Cisco PSTN gateway. T.38 via SIP. The sending device goes off hook. The sending device dials the number of the receiving device. The SIP session is then initiated by the sending gateway. The call manager, which is Cisco or Avaya, etc., determines whether the call will be handled locally or by a remote gateway based on the same routing tables that it uses for voice over IP, and the call is made. Upon detecting an answer tone, a SIP invite VoIP request is sent. The receiving gateway responds with 200 OK. The sending gateway performs a re-invite asking for a VoIP session. If the receiving gateway is capable of T.38, the call proceeds. If the receiving gateway is not T.38 capable, the VoIP call will revert to G711 mode or will be rejected, depending on the configuration. T.38 via H323. Request permission from the H323 gatekeeper. The sending device receives a Q931 transport address of the receiver. We set up the call. The sending device receives the H245 transport address of the receiver. Handshaking and negotiation. We determine the master-slave status and establish logical communication channels. RDP, RTCP addresses are established at each end. The T.38 transmission takes place. The logical channels are closed. We tear down the call and then release the resources. SIP trunks. In a typical voice over IP scenario, you have communication between your various office locations over WAN, but all of your calls to the outside world require a direct connection to the PSTN. You may have one PSTN connection shared by the entire organization, providing a single point of presence, or multiple locations can have a PSTN connection, allowing for least cost routing throughout the organization. Calls to the outside world enter the PSTN at a point closest to the destination. The problem with this scenario is cost. You're paying for both a data connection to the internet and a telephony connection to the PSTN. A SIP trunk allows your data connection to be your PSTN connection. With a SIP trunk, all of your calls are IP-based, and the point of presence is wherever your provider has offices. You may need to increase your overall network bandwidth, but the cost savings versus maintaining a direct PSTN connection is often more than 50%, making SIP trunking very attractive. When T.38 fax-over-IP is supported by your SIP provider, the WAN IP address of the provider becomes your SIP gateway, and the provider should specify their requirements for T.38 connections. Which fax-over-IP solution do I use? Well, I can't tell you that. It totally depends on the telephony system or the SIP trunk provider that you have. We get this information during the discovery phase of a Faxination deployment, or when we're doing general technical consulting. But I can tell you that we have one or more options for everything that you see here. Faxination 2016 includes 4 solutions for fax over IP. Dialogic Brooktrout TR1034 hardware, Dialogic Brooktrout SR140 software, Faxination fax over IP stack software, and XCAPI software. Each of these solutions have their pros and cons. All modern digital T1E1 TR1034 boards have a secondary Ethernet port for use in T.38 fax over IP mode. The operational mode is selectable within the Brooktrout configuration tool. T1E1 and T.38 modes cannot be enabled simultaneously. The Dialogic Brooktrout SR140 uses the same Faxination connector and the same Brooktrout configuration tool. It supports both SIP and H323 signaling, but it can only be configured to use a single gateway or call manager address. Faxination least cost routing is not possible. The Faxination fax over IP device connector supports T.38 with SIP signaling only. It supports multiple gateway configurations. XCAPI allows you to pick from a pre-configured list of SIP providers and telephony hardware that they've tested with. If they don't have a match for your environment, you can always choose generic SIP or generic H323 and manually configure it from there. As of release 3.5.44.0, the XCAPI controller wizard comes with configuration profiles for 36 SIP providers and 64 PBX systems. You can sign up for a demo at www.te-systems.de, install the Faxination CAPI device connector in evaluation mode, and try it out for yourself. The CAPI connector is what we used with the old Icon Diva boards, so it's been in the Faxination product for 15 years or more. Instead of talking to a CAPI abstraction layer that talks to a board driver which talks to a fax board, XCAPI is both the CAPI interface and a T.38 interface in one application. Fenestre support can help you determine the best solution for your environment. Alternatively, you can log into our support website and search for the interoperability lists under Find Solutions. If your telephony system doesn't support T.38 or the interoperability doesn't meet your requirements, a digital media gateway can be used. Fenestre recommends the Dialogic DMG series and the AudioCodes Mediant series. These devices convert whatever telephony standard your PBX can supply and makes it T.38 compliant. They range from 4-port analog appliances all the way up to multiple T1E1 spans and a single rack mount chassis. T.38 performance. Know your enemy. Packet loss, when a piece of transmitted data does not arrive at the destination or arrives too late to be utilized. Latency, the delay between the time a piece of data is transmitted and when it arrives at the destination. Jitter, the variation in the amount of latency over time. And bandwidth, the amount of data that a given network can support at any given time. Variations in overall network load during a fax transmission can result in packet loss, latency, and jitter. Quality of service, or QoS, can be used to prioritize your packets for voice-over-IP and fax-over-IP. However, it's never as simple as just enabling an option in a menu somewhere. All of your network equipment has to work together. Sometimes hardware like a switch or a firewall appliance will need a firmware update before it will honor the prioritized packets. Sometimes finding the single weak link in the chain can be very difficult. In extreme cases, you might even consider bringing in a network optimization specialist. Some common misconceptions about fax-over-IP. Is fax-over-IP faster than fax cards? No. T.38 transmissions rarely exceed 14.4 due to the hardware and software limitations or the network and line quality. Is it more reliable than fax cards? No. It's impossible or not cost-effective to guarantee quality of service over the WAN or between the endpoints. Less expensive than fax cards? Yes, it can be. If you have an existing voice-over-IP system, adding fax-over-IP hardware and/or licensing is usually cost-effective. Improves fax quality? No. T.38 encapsulates the standard T.30 transmission with all of the same limitations as standard fax. Is it easier to implement? Yes, it is. In many cases, all you need to do is configure the IP address of the telephony gateway. A clearly defined standard? No. T.38 is vague, and many interoperability issues exist between hardware and software vendors. Is it a mature technology? Well, yes and no. It's getting better, but there are still some interoperability issues between hardware and software vendors. And that's where Fenestre's consultants come in, and we can help you make the best decision for your environment. So given all of this information, why are so many organizations in the world so eager to move their fax solution over to fax-over-IP? There's a one-word, simple answer: virtualization. Fax-over-IP gives you the freedom to fully virtualize Faxination by eliminating the requirement for a physical fax device. Because fax-over-IP works over standard Ethernet, as the name implies, it can use any standard network interface card. Fenestre officially supports Faxination in both Microsoft Hyper-V and VMware environments. VMware has historically been the most popular virtualization platform, and even though it has been steadily losing market share over the last few years, that share has been going almost entirely to Microsoft. So between those two platforms, depending on who you ask, we cover about 85% of the virtualization market. There are other options out there, as you can see, but none of them have managed to crack the single-digit market share boundary. That said, we really didn't make any changes to the Faxination product to support virtualization. So if you want to run one of these other virtualization platforms, it will probably work okay. However, as a company, Fenestre only officially supports Hyper-V and VMware.